Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Let me introduce myself. My name is Fariza Rohmah. My study number is 410141937. And my friend is Tania. The study number is 410141907. We're going to explain about hypothesis testing. Okay, for the first, introduction to statistical tests. The second is testing the mean of mu, and third is testing a proportion P, and the last is question. What is hypothesis testing? Hypothesis testing is an act in statistics whereby an analysis test an assumption regarding a population parameter. The methodology employed by the analysis depends on the nature of the data used and the reason for the analysis. Hypothesis testing is used to assess the plausibility of the hypothesis by using sample data, such that may come from a live population or from a data generating process. Okay, the next slide is advantage of hypothesis testing. It is to help making decisions. For example, a candidate for mayor who wants to know which district has a low percentage of the population in recognizing himself. To make it efficient, the method is to take a sample from each district and then calculate the sample proportion. From the three sample proportion, the statistical test can be calculated. Then the hypothesis test can be carried out in relation to which district has not aligned itself, and he will make this district a priority over his campaign. Okay, the next is stating hypothesis. First, there is null hypothesis, and this is the statement that is under investigation or being tested. Usually, the null hypothesis represents a statement of no effect, no difference, or put another way, things have changed. And two is alternate hypothesis. This is the statement you will adopt in the situation in which the evidence or data is so strong that you reject null hypothesis. A statistical test is designed to assess the strength of the evidence data against the null hypothesis. For example, a car manufacturer advertises there is new subcompact model get 47 miles per gallon, and let mu be the mean of the mileage distribution for these cars. You assume that the manufacturer will not underrate the car, but you suspect that the mileage might be overrated. Okay, what shall we use for null hypothesis? The solution is we want to see if the manufacturers claim that mu equal to 47 miles per gallon can be rechecked. Therefore, our null hypothesis is simply that mu equal to 47 kg. We denote the null hypothesis as not mu equal to 47 miles per gallon. And B, the question is, what shall we use for alternate hypothesis? The solution is, from experience, with this manufacturer, we have every reason to believe that the advertised mileage is too high. If mu is not 47 mpg, we are sure it is less than 47 miles per gallon. Therefore, the alternate hypothesis is alternate mu less than 47 mpg. Okay, the next slide is the types of tests. First, there is left tile, and second is right tile, and three is two tile. If alternate hypothesis says that the parameter is less than the value claimed in null hypothesis. But now, if alternate hypothesis states that the parameter is greater than the value claimed in null hypothesis. And to tell if alternate hypothesis states that the parameter is different from or not equal to the value claimed in null hypothesis. This is the table of types of testing. Okay. The next is hypothesis test of mu given x is normal and standard deviation is null. The requirement, the x distribution is normal with no standard deviation. Then x bar has a normal distribution. The standard test statistics equal to z equal to x bar minus mu divided by standard deviation over the square root of n, where x bar equal to mean of simple random sample and mu equal to value stated in null hypothesis and n is sample size. This is the p-value of a statistical test. Assuming null hypothesis is true, the probability that the test statistic will take on value as extreme as or more extreme than the observed test statistic computed from sample data is called the p-value of the test. The smaller the p-value computed from sample data, the stronger the evidence against null hypothesis. This is p-value and types of tests. Let Gx bar represent the standard sample test statistic for testing mean mu using the standard normal distribution. That is, Gx bar equal to x bar mean minus mu divided by standard deviation over square root of n. The first left tail test. If null hypothesis is mu equal to k and alternate hypothesis is mu less than to k, that p value is z less than zx bar. This is the probability of getting a test statistic as low as or lower than zx bar. The two is right tail test. If null hypothesis mu equal to k and alternate hypothesis is mu greater than k, so p value equal to p z greater than zx bar. This is the probability of getting a test statistic as high or higher than zx bar. And the third is two-tailed test. If null hypothesis is mu equal to k and alternate hypothesis is mu not equal to k, so p-value is p-value divided by 2 equal to p z greater greater than the absolute value of Gx bar. Therefore, the value equal to the G greater than absolute of Gx bar. This is the probability of getting a test statistic either lower than minus absolute value of Gx bar or higher than the absolute value of Gx bar. And next is types of error. If we reject the null hypothesis, when it is in fact true, we have made an error that is called a type 1 error. On the other hand, if we accept the null hypothesis when it is in fact false, we have made an error that is called a type 2 error. The level of significance alpha is the probability of rejecting null hypothesis when it is true. This is the probability of a type 1 error. This is the table of type 1 and type 2 error. The third of null hypothesis. If null hypothesis is true and our decision do not reject null hypothesis, so the result is correct decision or no error. And if we reject null hypothesis, the result is type 1 error. If null hypothesis is false and our decision is type 2 error, our decision is to not reject null hypothesis, the result is type 2 error. And if we reject null hypothesis, the decision is correct decision or no error. And this is the table of probabilities associated with a statistical test. And if null hypothesis is true, and our decision, we accept null hypothesis as true, and the result is correct decision with corresponding probability 1 minus alpha. And if we reject null hypothesis as false, the result is the type 1 error with corresponding probability alpha, called the level of significance of the test. And if null hypothesis is false and our decision is accept null hypothesis as true, the result is type 2 error with corresponding probability beta. And if we reject null hypothesis as false, the result is correct decision with corresponding probability 1 minus beta all the power of the test. The probability of making a type 2 error is denoted by the Greek letter. The pronoun is beta, and the quantity 1 minus beta is called the power of a test and represent the probability of rejecting null hypothesis when it is in fact false. And this is the concluding a statistical test. How to conclude a test using the p-value and level of significance alpha. If p-value less than equal to alpha, we reject null hypothesis and say the data are statistically significant at the level of alpha. If p-value greater than alpha, we do not reject the null hypothesis. And this is the basic component of a statistical test. A statistical test can be thought of as a package of 5 basic ingredients. One, null hypothesis and alternate hypothesis and preset level of significance alpha. If the evidence or against null hypothesis is strong enough, we reject null hypothesis and adopt alternate hypothesis. The level of significance alpha is the probability of reject null hypothesis when it is in fact true. And two is test statistic and sampling distribution. These are mathematical tools used to measure compatibility of sample data and the null hypothesis. And the third is p-value. This is the probability of obtaining a test statistic from the sampling distribution that is as extreme as or more extreme as specified by alternate hypothesis than the sample test statistic computed from the data under the assumption that null hypothesis is true. And the fourth is test conclusion. If the value less than equal to alpha, we reject null hypothesis and say that the data are significant at level alpha. If the value greater than alpha, we do not reject null hypothesis. And five is interpretation of the test result. Give a simple explanation of your conclusion in the context of the application. And then testing new when standard deviation is known. The requirement is let X be a random variable appropriate to your application. Obtain a simple random sample of size n of X value from which you compute the sample mean X bar. The value of standard deviation is already known perhaps from the previous study. If you can assume that X has a normal distribution, then any sample size n will work. If you cannot assume this, they use a sample size n greater than equal 30. And the procedure is first, in the context of the application, set the null and alternate hypothesis and set a level of significance alpha. And the second is use the null standard deviation, the sample size n, the value of X from the sample, and U from the null hypothesis to compute the standard sample test statistic. And the formula is Z equal to X bar minus mu divided by standard deviation over square root of n. And the third is use the standard normal distribution and the type of test, one tile of two tile, to find the p-value corresponding to the test statistic. And the fourth is conclude the test if p-value less than equal alpha, then reject null hypothesis. If p-value greater than alpha, then do not reject null hypothesis. And five is interpret your conclusion in the context of the application. Next is testing mu when standard deviation is unknown. Requirement is let X be a random variable appropriate to your application. Obtain a simple random sample of size n of X value from which you compute the sample mean X bar and the sample standard deviation S. If you can assume that X has a normal distribution or simply shape and symmetric distribution, then any sample size n will work. If you cannot assume this, use a sample size n greater than equal 30. And the procedure is first, in the context of the application, set the null and alternate hypothesis and set the level of significance alpha. And the second is use X bar standard deviation. I'm sorry, is use X bar and And from the sample, with mu from null hypothesis, to compute the sample test statistic. The formula is T equal x bar minus mu divided by S over square root of n with degree of freedom is n minus 1. And next, use the student T distribution and the type of test, one tile or two tile, to find or estimate the p-value corresponding to the test statistic. Therefore, it concludes the test if p-value less than equal to alpha, they reject null hypothesis. If p-value greater than alpha, then do not reject null hypothesis. And interpret your conclusion in the context in the application. Okay. Next is make a conclusion. How to conclude test using the critical IQ method. The first, compute the sample test statistic using an appropriate sampling distribution. Two, using the same sampling distribution, find the critical value as determined by the level of significance alpha and the nature of the test, right tail, left tail, or two tail. And the third is compare the sample test statistic to the critical value. Okay, for a right tail test, if sample test statistic greater than equal critical value, so reject null hypothesis. If sample test statistic less than critical value, fail to reject null hypothesis. B, for a left tail test, if sample test statistic less than equal critical value, so reject null hypothesis. And if sample test statistic greater than critical value, and we fail to reject null hypothesis. And C, for a two-tailed test, if sample statistic lie at or beyond critical value and reject null hypothesis. If sample that statistic lies between and beyond critical value, we fail to reject null hypothesis. And next will be explained by my friend Nova Tania. Please, Nova.
Okay, good morning, friend. Can you hear my voice?
Yes.
Okay. In this presentation, let me to continue the presentation from Anna from group 3. This is the type of null and alternate hypothesis for test of proportion. The first kind is a left tail test. The second is right tail test, and the third kind is two tail test. For null hypothesis, for left tail, right tail, and two tail is same. Null hypothesis is P equal K, and for left tail test, alternate hypothesis is P less than K, and for to right tail test, alternate hypothesis is P greater than K, and for two tail test, alternate hypothesis is P is not equal to K. Next, Anna, please next. Yeah, this is testing proportion P. The first requirement, consider a binomial experiment with n trials, where P represents the population probability of success and Q is equal to 1 minus P, represent the population probability of failure. And then let R be a random variable that represents the number of success out of the n binomial trials. The number of trials and should be sufficiently large so that both NP and NK greater than 5, and note that use P from the null hypothesis. In this case, P hat is equal to R over N can be approximated by the normal distribution. And the procedure, the first, in the context of the application, set the null and alternative hypothesis and set the level of significance alpha. And the second, compute the standard sample test statistic. The formula is C is equal to P hat minus P over square root of PQ over N, and then where P is the value specified in null hypothesis and Q is equal 1 minus P, and the third, use the standard normal distribution and the type of test, one tile or two tiles. Find the p-value corresponding to the test statistic. And the fourth, conclude the test. If the p-value we get less than or equal alpha, then we must reject null hypothesis. And then if we get the p-value greater than alpha, then we must do not reject null hypothesis. And then the last, interpret our conclusion in the context application. I'm sorry, I will explain in bahasa. Jadi, untuk testing proportion T, syaratnya yaitu NP dan NQ itu harus lebih dari 5. Jadi kita jadi NP yang kita miliki dan NQ yang kita miliki itu harus lebih dari 5. Di mana P itu merepresentasikan sebuah peluang dari kita itu sukses dalam percobaan. Kemudian untuk Q itu 1 dikurangi P rumusnya. Untuk PTK sendiri itu P hat sendiri itu rumusnya R per N, di mana R itu sebuah variabel yang merepresentasikan banyaknya sukses dari banyaknya percobaan yang kita lakukan. Rumusnya sendiri itu yang pertama yang harus kita lakukan yaitu kita harus menyatakan hipotesis nolnya dan alternatif hipotesis yang kita miliki itu berapa dan set level alpha yang kita miliki itu berapa. Yang kedua, nilai yaitu P hat dikurangi P over akar dari PQ over N, di mana P itu nilai spesifik yang kita spesifikkan di H0, dan Q itu yang seperti yang sudah saya jelaskan 1 min P. Kemudian kita menggunakan normal distribution dan kita sesuaikan dengan tipe dari data yang kita miliki, one tile or two tiles. Kemudian kita temukan p-value berdasarkan tes statistik yang sudah kita lakukan yaitu Z. Kemudian untuk kesimpulannya, kalau p-value yang kita dapatkan itu ternyata kurang dari atau sama dengan alpha, maka kita harus menolak H0 Dan jika p-value-nya lebih dari apa, maka kita yang kita lakukan adalah tidak jadi menolak ke nol. Kemudian kita buat interpret sesuai dengan konteks soal yang kita miliki. Anna, please, next. This is a value for student distribution. Is so useful to we if we solve the problem with test. Next. Anna, please next. Anna, please next. Yeah. Okay. Review. Yeah. This is a question. For example, the basic computation testing mu, standard deviation unknown, and then the question, a random sample has 49 values. The sample mean is 8,5 and the sample standard deviation is 1,5, and then use a level of significance of 0,01 to conduct a lifestyle test of the claim that the population mean is 9,2. The first question, is it appropriate to use student p-distribution? If appropriate, explain it, and how many degrees of freedom do we use? And the two questions, what are the hypotheses? And C, compute the sample test statistic T. And D, estimate the p-value for the test. And E, do we reject or fail to reject null hypothesis? And the last, interpret the result. Anna, please next. Okay, from the question, for A, we know that in question, the sample n is equal to 49, and then because n is equal to 49, this is more than 30, so the sampling distribution of the sample mean x bar is approximately normal, and because population standard deviation is unknown, so we use the student t distribution because we do know about standard deviation population. We just have the sample standard deviation, and then the degree of freedom is the sample size decreased by 1. So we have the df is equal n minus 1, 49 minus 1, and then we get the gf is equal to 48. And then for B, state the hypothesis. By the question, we know that the null hypothesis is mu is equal to 9,2, and then the alternate hypothesis is mu less than 9,2, and we know that this is a type of lifestyle test. And then for C, x bar is equal to 8,5, and mu is 9,2, and sample standard deviation is 1,5, and n is equal to 49, and then we use the T formula, and then we include the number to the formula, so we get the T is equal to 8,5 minus 9,2, over 1,5 over square root of 49. So we get the t approximately minus 3,27. Next, please. Next, please. Okay. Then for T, the P value, because we have the df, degrees of freedom is equal to 48, and T approximately minus 3,27. So based on the table 6 in this, we know that for group 1 in the last presentation, for the one tile area, I'm sorry, this is not complete. This space is 3,27 fall between 2,990 and 3,520. So we have the p-value in the interval. And then for E, because we have the interval P in like this, and alpha is equal to 0,001, we can conclude that P less than alpha. So we choose to reject the null hypothesis. And then for F, because we reject the null hypothesis, so we accept the alternate hypothesis. There is the population mean is less than 9,2. Okay, this is my explanation. I'm sorry if you can understanding my explanation. If you want to ask, please open on your mic. I think not yet. If no question, so we have the question for you. Please, Anna, next. This is the question. Please, you solve the question, and then one or two of you explain your explanation. I give you 5 minutes to solve this question. Please, one of you explain your answer. And if you not understand about the material because confused in bahasa, You can ask me or Anna to explain with bahasa. The reference of our material in class edition 10, you can looking for the material in the breast.
Okay, friend. If someone don't solve the question, or we can explain again if you don't understand about the material. Okay, friend.
Assalamualaikum.
Yes, Waalaikumsalam.
Uh, I'm sorry. Here, I want to ask about previous
Previous, previous slide. Filter, clear,
words that I can understand it
filter
easily.
your
Hello, can you hear my voice sorry. I still don't understand about null hypothesis and alternate hypothesis. Please explain it with simple word that I can understand.
Oh, okay. White filter, I want to explain. This is the null hypothesis, and this is alternate hypothesis. I explain in bahasa. Ya, Firda? Or
Yes. Both of them is no problem. That please explain it with explain it. Yes.
bahasa. Jadi ada dua hipotesis. Di sini ada hipotesis nol sama hipotesis alternatif. Kalau hipotesis nol itu biasanya di statement yang digunakan tidak berubah, berarti tidak ada perubahan dan stuck kayak gitu. Jadi misalkan langsung aja ke contohnya. Jadi karena manufaktur it is new subcompact model gap 47 dapat berlari 47 mil setiap galonnya. Jadi ini pernyataan dari pabrik mobilnya. Nah, that new the mean of mile distribution for this car. Nah, kamu mengasumsikan bahwa manufaktur ini kayaknya itu underrated, but you suspect the mill may be overrated. Berarti kayaknya nggak mungkin deh kalau misal mobilnya itu kalau menghasilkan memerlukan 40 berjalan sejauh 40 mil per galon. Kayaknya ini terlalu melebih-lebihkan gitu. Jadi untuk kita gunakan hipotesis nolnya itu mu sama dengan 47 mil per galonnya. Nah ini tuh kayak membuktikan bahwa itu mau diterima atau ditolak. Jadi our null hypothesis is simply that mu equal to 40 mile per gallon and not is mu equal to 47. Dan terus hipotesis alternatifnya yang mau kita buktikan itu bahwa pernyataan dari pabriknya itu salah. Jadi kita punya hipotesis lain, yaitu alternatif hipotesis. Nah, ini tuh ini tuh kayak pernyataannya itu terlalu tinggi. Jadi jika mu is not 47 miles per gallon, we are sure it is less than 47 miles per gallon. Therefore, the alternate hypothesis is mu less than 47. Gitu. Jadi kita mau membuktikan bahwa pernyataannya ini itu tuh nggak benar. Jadi ditolak gitu. Jadi kita punya hipotesis nol dan hipotesis alternatif. That's it. You can reset that or you confused. Begitu deh. Ya. Deh. Fear. Okay, next we next to the question again, and okay, anyone can solve the question. Please open your mic.
Excuse me, Anna.
Yeah, Rian.
Yes, I want to try to answer the question for your group.
Mm-mm.
Uh, in the number 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 A,
Okay, Firda, don't worry.
number A, we know that number of trial is
I'm sorry, P. Please review slide.
I'm
Yeah,
sorry,
this
Anna.
is
Yeah.
The question is different from the previous.
Ah, ini.
Excuse me, Anna.
Yeah.
Uh, I've tried to the previous question with question of random sample of 13 binomial previous question, and I have sent my solution to your WA,
I can open. Wait.
but I just do A, B, C, and D for E and F. I don't know how to
Mm-mm.
answer it.
Upi. Please next slide.
Yeah.
Yes, this is
Can you see your answer in here? Mungkin.
Yes, pardon.
Can you show the answer in here?
Okay, wait. But Gustin Rahma Lutfiana is presenting.
Mm,
Augustine. Uh, wait a minute, yes. Still downloading. Gustin. Excuse me, Upi. I have sent my answer to your WA. Can you share screen my answer?
Okay. Share.
I forget to turn off the mute. Okay, this is my answer. We have n is equal to 13, r is equal to 12, and p is equal to a half, 0,5. Then we have q is 1 minus 0.5, 0.5, and this 0, 0.05. Normal distribution can be used for p distribution if n times p is greater than or equal to 5 and n times q greater than or equal to 5, and to both of them is satisfied, so the condition is satisfied, both of them is right. And for the hypothesis, uh,
I'm
it's
sorry, Mupin.
yes.
Uh, in the your answer is NP
uh,
greater than or equal to 5.
oh,
Is it true?
I'm sorry, I think that's terbalik. Oh ya, ya, ya. Thank you Afrian.
I
Okay,
think
this is
the true answer is NP greater than 5, not
mhm.
greater than or equal to.
Oh, greater than. Okay, okay, okay.
Yes,
I'll check
in
it
the
again. Okay. And next
technique.
hmm? And next explanation is C. Compute P head. P head is equal to R per n, and we get 0,4. And for p value of the test satisfied, we have this formula, and I compute is about it's about negative 1.1 for p formula. Oh, sorry, this is terbalik. P value using table 5, the previous table, and p we get p is equal to 0,27. For a and f, I don't know how to answer it. Okay, that's all my answer.
Okay, thank you, Mubin, for your answer and your presentation. For the first, for question A, you are right, but like Afrian said, that the NP must be greater than 5, not greater than or equals. And then for B, you are right, and for C, you are right too. But in D, for p-value, you is incorrect because the p-value, because this is a two-tile test, and we know that the p-value for two-tile test, the 2 times the p, uh, please next, and
Okay, thank you
the,
for the correction.
yes, the result p-value is 2,7 114, and then because the alpha is equal to 0,05, and we know that the value is 2,713, so we conclude that the value greater than alpha, so we uh, don't reject the null hypothesis. And then the interpret, there is the population proportion for success is equal to 0,5. There is no sufficient evidence to support the claim that the population proportion of success does not equal 0,5. Please, the previous slide. But sorry. For to get the p-value of C, we can see in the PPT from group 1 from Sabita and Muntahihun in last and from the group 1. Okay, this is my explanation. I'm sorry if me or Anna can explanation not clear. If you confused and want to ask about the material, you can ask to me or Anna via WhatsApp group. Okay, I think enough for discuss today. I'm sorry for the mistake from me or Anna. I think enough. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you.
Papa, don't forget homework.
Oh yeah. I and Anna give you homework in PPT. I will share in WhatsApp group.
Okay.
After we done the discuss today. Thank you.
Thank you, guys.